Problem 21.2. The question asks us to draw a diagram, and then we need to show the balance equation of a reaction, write the notation for a Voltaic cell, and the information that is given to us is we have a chromium bar in a chromium nitrate solution in the first half cell, and in the second half cell we have silver bar in a silver nitrate solution, and the potassium nitrate is used as a salt bridge. From measurement, it indicates that the chromium electrode is negative relative to the silver electrode. So when the chromium electrode is more negative than the silver, it means that the chromium electrode will be the negative electrode or anode. Let's start by drawing the diagram. We have two beakers. In each beaker we have a electrode. This is the first electrode. Label it as a negative N for anode. And this electrode is actually a chromium solid. And then we have a second electrode in the second beaker. Okay, it is labeled as a silver. And this is our positive N, a positive terminal. Both of these two electrodes is connected by a voltmeter. And then both of these two electrodes in the electrolyte. For the chromium, the electrolyte is the chromium nitrate. So in this solution, okay, we are actually having a chromium ion and also nitrate ion. And then silver is dipped into a solution of silver nitrate, so that in this solution we are actually having Ag plus and nitrate ion. Both of these two beakers is then connected by a salt bridge. In which the salt bridge that we use is the potassium nitrate. That we have a potassium ion and nitrate ion that will neutralize or balance the ions in both of the beakers. The K plus goes to the cathode, while nitrate will go to the anode. And since that the chromium half cell, the Cr half cell, is the negative terminal, so it is an anode. So anode, it is a source of the electron. So the electron is moving from the chromium electrode towards the silver electrode. So we have to show it by using this arrow and label electron there. So this is our Voltaic cell. So this side is the anode side, and this is the cathode side. We know in anode, oxidation occurs. It is when the chromium solid from the electrode is oxidized, releasing its electron, turns to Cr3 plus aqueous, plus 3 electron. And then in cathode, we know that the reduction occurs. What's being reduced is actually Ag plus, the electron that is donating or contributing by the source of the electron, which is this half cell, will go to the silver half cell, and it will receive by the silver plus ion, and the silver plus ion will undergo reduction and it turns to Ag solid. So if we write the overall equation of a reaction, so the overall will be Cr solid plus with 3Ag plus aqueous turns to Cr3 plus aqueous plus 3Ag solid. So if you want to write the notation of this Voltaic cell, it will be Cr solid slash Cr3 plus aqueous double slash to represent or to separate between the two half cell, and then Ag plus aqueous single slash to represent different phase tends to Ag solid. So this is the cell notation for this Voltaic cell. Okay, the equation for the first half cell, equation for the second half cell, and this is the overall equation. So please make sure that we label all in our diagram of the Voltaic cell. So this is the example of the Voltaic cell that is using inactive electrode. So in this case, the inactive electrode that we use is a graphite for both half cell. So in anode, the reaction is the oxidation reaction of iodide when I minus turns to I2. So this I minus release to electron to produce I2 solid, while what happened in the cathode is the reduction of the MnO4 minus turns to Mn2 plus in the presence of acidic medium. We have H plus and also H2O. So the overall equation of this reaction is 2MnO4 minus plus 16H plus 10 iodide produce 2Mn2 plus 5I2 plus 8H2O. Since that this Voltaic cell is using inactive electrode, so we'll have the graphite in the notation. Graphite single slash I minus aqueous single slash I2 solid double slash MnO4 minus aqueous comma H plus, no slash because they are the same phase, which is aqueous, comma Mn2 plus single graphite. Why this reaction is using inactive electrode? It is because both of the two components, iodide and iodine, cannot carry the electron. They are not able to carry the electron, so they cannot transfer the electron through it. Okay, and same goes with the MnO minus, Mn2 plus. Both of them are in aqueous state, so they need to have a solid electrode to transfer or to receive the electron. That is why graphite is used in this example.